Whether you're a tech enthusiast, industry professional, or just curious about the future of AI Agents Unleashed will keep you informed and inspired. Buckle up and get ready to unleash the potential of AI.
Welcome to our deep dive today. We're going to be exploring how AI is learning to write code and even learning to write it better.
It's a fast-moving area. There's lots to talk about.
For sure. We're mainly diving into the survey paper from December 2024, Enhancing Code LLMs with Reinforcement Learning in Code Generation, a survey. And it really gets into how AI is going beyond just spitting out code and actually starting to learn how to write it well.
Yeah, it's moving away from just giving the AI a ton of code to training it more like how humans learn.
Exactly. It's like the AI has a coding tutor, and that tutor is reinforcement learning, or RL. You've probably heard of it, but think of it like training a dog. You know, you give it commands, it tries things out, sometimes it gets it right, other times it learns from its mistakes. Now imagine that dog is learning to code.
The paper starts with, some basics, explains code generation, basically using plain English to describe what you want your program to do, and then having an AI write the code for you. Wild, huh?
It is. But even without RL, the paper points out that traditional code generation has, its problems. LLMs, the AI models used, sometimes write code that's overly complex, even if it's technically correct.
It's like they're showing off their coding skills instead of just going for the simplest solution.
Yeah, like get to the point AI. That's where RL comes in, though. The paper suggests that RL can actually address these sorts of issues.
So let's dig into RL a bit more. At its core, it's about letting the AI experiment and learn from those experiences. It's not just passively absorbing code. It gets to try things, get feedback, and adjust its approach.
And what's really interesting is the idea of a reward. The AI gets a reward when it produces good code, like code that passes tests, is efficient, follows those best practices.
Think of it as like positive reinforcement, right, for good coding behavior. And over time, the AI gets better at writing code that not only works, but is elegant. Kind of like what a human expert would do.
All right, let's get into some real-world examples. The paper looks at systems like CodeRL, PPO Coder, and Pangu Coder 2, each with its own way of using RL.
Yeah, so CodeRL combines a pre-trained language model with deep reinforcement learning techniques. And the feedback it uses is based on whether the code passes unit tests.
So it's really laser-focused on making sure that code works, not just looks fancy.
Right. Then there's PPO Coder, which uses what's called proximal policy optimization, or PPO. Basically, PPO helps the AI learn more steadily, avoid making big changes that might, break its code.
It's like taking baby steps towards becoming a master coder.
Exactly.
Yeah.
And finally, there's Pangu Coder 2. Now, this one's interesting because it uses something called ranking reinforcement from human feedback, or RRHF. It learns from humans directly. They rank different code samples, so it starts to code more like a human developer would.
So it's getting feedback from the pros. I bet that helps it level up quickly.
Definitely seems to. But here's where it gets even cooler. This isn't just theoretical stuff. These RL-powered systems are already being used in tools that developers are using right now.
So we might already be benefiting from this without even realizing it.
Maybe. The paper highlights some real-world examples, like GitHub Copilot, which uses RL to help developers write code faster and with fewer errors.
Oh, I've heard of that. Doesn't it use AI to suggest code snippets and even entire functions while you're coding?
That's right. It's almost like having a pair programmer right there in your IDE.
And it's not just individual tools like Copilot. The paper talks about the broader impact of RL on what it calls end-to-end software development. So RL is being used to improve things like software testing, resource management, and even those deployment processes.
Right. RL's kind of touching almost every stage of the software development lifecycle.
So it's not just about writing code, it's about managing the entire process more efficiently. That's pretty incredible, but I'm sure there are still challenges, right?
Of course, we're still pretty early in this field. There's a lot of cool stuff happening, but also plenty of room to grow.
So what are some of the biggest hurdles, the ones that researchers are facing?
One of the key ones the paper highlights is the need for better data sets. Just like any AI, code LLMs are only as good as the data they're trained on.
So garbage in, garbage out, right? If the training data is full of buggy or poorly written code, the AI is going to learn some bad habits.
For sure. That's why researchers are really pushing for more diverse and comprehensive data sets that cover a wider range of tasks, languages, and best practices.
It's not just about quantity then, it's about quality too. We need data sets that are carefully curated and clean to make sure that AI is learning from the best examples.
Exactly. Think of it like a gourmet chef, right? Carefully
Yes.
selecting the freshest ingredients for their recipes.
I like that. This kind of brings us to another challenge the paper points out. It's not always easy to measure how good AI generated code actually is. Sure, it might work, but is it efficient? Is it secure? Is it readable?
You're getting at the need for better benchmarks. We need more sophisticated ways to evaluate the quality of AI-generated code that go beyond just checking if it, runs without errors.
So we need benchmarks that look at things like how well the code is written, how efficient it is, how secure it is.
Yeah, and these benchmarks need to be constantly evolving, both as the AI tech gets better and as the demands of software development change.
Sounds like we're just scratching the surface of what's possible with RL and code generation. Challenges for sure, but also a ton of opportunity.
Absolutely. And in the next part of our deep dive, we'll explore those opportunities and how RL is really shaping that whole software development lifecycle. Stay tuned. Welcome back to our deep dive into how AI is learning to write code.
We talked about how reinforcement learning is kind of like giving AI a coding tutor, helping it get better over time.
Right, and we even touched on some real-world tools like GitHub Copilot that are using RL to help developers right now.
Now, you might be thinking, okay, AI can write code, but how do we know if it's any good?
That's a great question, and that's where this paper gets into the kind of tricky world of evaluating AI-generated code. It's not as simple as just seeing if it, runs without errors.
Right, because you could have code that technically works, but it's just a nightmare to read or maintain. Like, imagine a house that's structurally sound, but has all the wiring exposed and the plumbing's leaking everywhere.
Yeah, that's a great analogy. So the paper gets into the metrics and benchmarks that researchers use to evaluate these systems.
It starts off talking about metrics, which are ways to measure different aspects of code quality. Some of these are actually borrowed from other fields, like machine translation, where you're comparing how similar a machine-generated text is to one written by a human.
Right, but applying those same metrics to code isn't always perfect. Code has, its own unique characteristics.
It's like judging a painting based only on the colors used, without considering the composition or the brushstrokes.
Exactly. So researchers have come up with metrics specifically designed for code, like CodeBLEU.
Code BLEU. What makes that one so special?
Well, it goes beyond just comparing, words and actually looks at the code's underlying structure to better compare it to human written code.
So it's like getting a deeper understanding of how the code's put together, not just what it says on the surface.
Right. But even these specialized metrics have their limits. We also need to know if the code actually does what it's supposed to.
And that leads to what the paper calls execution-based metrics. These actually run the code and see what happens.
It's like putting that house to the test, turning on the faucets, flipping the light switches, making sure the roof doesn't leak.
Haha, I love it. So these metrics measure things like how often the code produces the correct output, how many test cases it passes, how efficiently it runs.
And this is where reinforcement learning really comes in. Remember those rewards we talked about? Well, in those RL-based systems, the reward is often tied to how well the code performs when it's executed.
So if the code passes all the tests, the AI gets a big virtual high five, and that encourages it to keep producing code that's not just syntactically correct, but also actually works.
Exactly. Helps to kind of align what the AI thinks is good code with what actually works in practice.
But the paper goes beyond just individual metrics, right? It also talks about benchmarks.
Yeah, benchmarks are like standardized sets of problems or tasks that are used to evaluate different code LLMs. Think of them like obstacle courses for AI coders.
So some benchmarks might be like write a function to sort a list of numbers, and others are more complex, like implement a machine learning algorithm.
Right. Each benchmark tests, different coding skills and abilities, gives us a more comprehensive view of how well these AI systems perform.
We're not just testing if they can jump over one hurdle, we're putting them through a whole obstacle course to see what they can really do.
The paper mentions several popular benchmarks like Human Evil, MBPP, and APPS. Each one has its own focus and difficulty level.
Like different coding challenges, from beginner to expert level to see how the AI stacks up.
But even with all these benchmarks and metrics, the paper acknowledges there's still work to be done. Many benchmarks focus on, functional correctness and code structure, but not so much on other things like security or maintainability.
Yeah, it's one thing for the code to work, it's another thing for it to be secure, scalable, and easy for others to understand.
Exactly. And as these AI systems get even more sophisticated, we're going to need better benchmarks that can capture these kind of nuanced aspects of code quality.
Speaking of getting more sophisticated, the paper moves into the broader impact of RL on that whole software development lifecycle.
Right. It's not just about writing code. It's about everything from design to testing to deployment.
Okay, so let's break that down. We talked about testing earlier. How is RL changing that?
Traditionally, software testing has been very manual and super time-consuming. But with RL, we're starting to see systems that can automatically generate test cases and even, identify potential vulnerabilities.
So it's like having an AI quality assurance team working 24/7, making sure that code is solid.
Exactly. This not only saves developers a ton of time, but leads to more thorough and reliable testing.
That's a win-win. What about resource management? How is RL making a difference there?
Well, developing and running software takes a lot of resources, computing power, memory, storage, and so on. Managing those efficiently is really important.
It's like running a household budget.
Yeah.
You got to be mindful of how much electricity you're using or how much food you're wasting.
Great way to put it. And RL is proving to be really useful for optimizing those resources in software development.
So the AI is like deciding how much memory to allocate to a program or when to spin up a new server in the cloud.
Yeah, exactly. RL-based systems can analyze resource usage, predict future demand, and dynamically adjust allocation to make sure things run smoothly without, wasting resources.
It's like having an AI financial advisor for your software, making sure you're not overspending and you have enough to handle those unexpected spikes in demand.
And this is even more important with cloud computing, where you're often billed based on how much you actually use.
So RL's helping developers save money and keep their applications running efficiently, even when things get really busy. But the paper doesn't stop there. It even talks about RL impacting the deployment process, that final stage of getting software out into the world.
Right. Deploying software can be really complex, especially for large applications. You have to make sure that all the pieces are working together, that the system can handle the traffic, that there's a plan if something goes wrong.
It sounds like orchestrating a massive stage production with hundreds of actors and sets, costumes, lighting cues, and so on.
Yeah. And RL is actually being used to automate and optimize many of those tasks. For example, it can help determine the best order to deploy components, predict potential bottlenecks, and even, automatically scale resources up or down based on demand.
So it's like having an AI stage manager who keeps the show running smoothly no matter what.
Exactly. This level of automation makes deployment faster, more efficient, and reduces the risk of, costly human errors.
It seems like RL is really touching every part of software development, making things faster, more efficient, more reliable. But I gotta ask, what about the human developers in all of this?
That's a valid question. One of the biggest concerns people have is about, job displacement. If AI can do all this, what happens to the developers?
Right. Are we automating ourselves out of a job?
The paper argues that instead of replacing human developers, RL is more likely to augment their skills and make them even more effective.
So it's like saying that, the invention of the power drill didn't replace carpenters, it just gave them a better tool to use.
Precisely. Developers will still need to understand how to use these AI tools, guide their decisions, and ensure that the code meets those specific requirements of the project.
So it's more about AI becoming a powerful tool in the developer's toolbox, freeing them up to focus on those, more creative and complex aspects of their work.
That's the optimistic view, and I tend to agree.
Yeah.
But it's important to be aware of the potential challenges and make sure we're prepared for the changes these technologies are going to bring.
This has been incredibly insightful so far. I'm already starting to see how RL is shaping the future of software development.
And we're not done yet. In the final part, we'll zoom out even further and discuss the broader implications of RL in code generation and what it might mean for the future of software and even, society as a whole. Stick with us.
Welcome back to our deep dive into AI and code generation.
We've covered a lot, from those RL algorithms to the tools that are already using it in the real world.
Right. And now we're going to step back and look at the bigger picture. What does the rise of all this AI-powered code generation mean for the future of software development?
It's a question a lot of people are asking, and the paper actually offers some pretty interesting thoughts on that.
One of the more obvious benefits is, increased productivity, right? If AI can help us write code faster and with fewer errors, it frees up developers to focus on the more challenging stuff, the more creative tasks.
Yeah, it's like giving every developer a team of super efficient assistants who handle all those tedious parts of coding.
And that could lead to, like, a much faster pace of innovation. Imagine prototyping new ideas, building new apps, all in a fraction of the time it takes now.
That's the real potential here. AI could become this catalyst for creativity and problem solving, letting developers explore things that were, just out of reach before.
But we can't ignore the downsides, right? Earlier, we talked about that concern of job displacement. As these AI tools get more powerful, what happens to all the human developers?
Yeah, it's a valid concern, and the paper does acknowledge that. But it argues that instead of replacing developers, AI is more likely to just, enhance their skills, make them more effective.
It's like that shift from hand-drawn animation to computer animation. It didn't get rid of the animators, it just gave them new tools and opened up new possibilities.
Exactly. And just like those animators had to learn new skills to adapt, developers are going to need to learn how to work with these AI systems effectively.
So it's less about being replaced and more about learning to collaborate with AI, using its strengths, but still bringing our own unique human skills and creativity to the mix.
And as we adapt to this new way of working, we might even see entirely new jobs and specializations emerge, ones we can't even imagine right now.
It's like how the internet created this whole new ecosystem of jobs and industries that just didn't exist before. Who knows what's coming next?
And as those possibilities unfold, AI might even change the way we think about code itself. Right now, we interact with code through keyboards, text editors, but what if AI enabled more intuitive ways to code?
Like using voice commands to write code or just describing an idea and having the AI turn it into software.
Yeah, exactly. It could break down the barriers between human thought and what the machine can actually execute, and that would make coding accessible to so many more people.
Imagine a world where anyone, regardless of their background, could bring their ideas to life through code. That'd be pretty amazing.
You would really democratize software development, right? Give people from all walks of life the power to create and innovate.
But with that power comes responsibility. As these AI systems get more sophisticated, we need to be very aware of the potential biases they might pick up from their training data.
That's a huge point. If the data used to train these systems reflects existing biases, well, those biases could be amplified in the code that they produce.
And that could have real-world consequences, especially if that code is being used in systems that make decisions about people's lives, like loans, healthcare, the justice system.
That's why it's so crucial to approach AI development with a really strong ethical framework, making sure these systems are designed and used fairly, transparently, and that they're accountable.
It's not just about code that works. It's about code that reflects our values and helps build a better world.
And that takes a real collaborative effort. It's not just computer scientists, it's bringing in ethicists, social scientists, policymakers, everyone.
These conversations need to be happening now while these technologies are being developed so we can steer them in the right direction.
Because the future of software development isn't just about the tech. It's about building a future where technology helps us create a more just and equitable society for all.
It's been awesome exploring this with you. We've gone from those RL details to, this grand vision of a future shaped by AI.
And even with the challenges, I'm really excited to see what comes next.
This deep dive has given us a lot to think about, and hopefully it sparked some curiosity in our listeners too.
If you want to learn more, definitely check out the paper we've been discussing. It's a great read, even if you don't have that technical background.
And remember, this is just the beginning of the conversation. AI is going to keep evolving, and we'll be here to, guide you through the latest stuff and help you navigate this whole new world.
Thanks for joining us on this deep dive. We'll be back soon with more fascinating topics to explore. Until then, keep learning, keep questioning, and keep pushing the boundaries of what's possible.
And who knows, maybe someday you'll be writing code alongside an AI, creating something truly incredible.